Good day, everyone. So good morning, good afternoon, or good evening. So I know that we are already in February, but I would like to wish you all a happy new year and of course a happy lunar new year. And so we are back. We are on the second year of the ITU's webinar series on digital transformation for cities and communities. We are pleased to welcome you all to episode 13 on architecting the web of things. So this episode is brought to you by ITU in coordination with Web of Things Working Group of the World Wide Web Consortium, or W3C. So before we start, we would like to know where you are connecting from. So do drop a quick message stating your name and the country from which you are connecting from. So without further delay, I would like to give the floor to Dr. Chase Sibley, Director of the Telecommunication Standardization Bureau at the ITU, to give us his opening remarks.
Thank you very much. Very good day, everyone. As Kiara said, I wish you, all of you, your families, happy and healthy New Year. It is my pleasure to welcome you to episode number 13 of the ITU webinar series on digital transformation for cities and communities. Today's webinar is dedicated to the same architecting the Web of Things. It is organized with coordination with the Web of Things Working Group at the World Wide Web Consortium, W3C. I thank our friends at W3C for your support. Just reminding myself, as already touched more than 10 years ago, I have some chance to learn about Web of Things. At that time, I was a chairman of the IoT group in ITUT. I'm very happy. I'm really glad we are now get together of this webinar, the meeting together both experts between ITU and W3C. The Web of Things aims to enable scalability and interoperability in IoT architecture. And the WT can significantly boost the performance of IoT platforms across the sectors, counter IoT fragmentation, and enhance smart city applications. In this regard, the standards are crucial for meeting the technical and architectural requirements of the Web of Things and ensuring that users have a shared understanding of this approach. ITU standardization work for the Internet of Things and the smart cities and communities is led by ITUT Study Group 20. As we will learn today, Study Group 20 has developed a series of standards in this area, including ITUT recommendation wide 4400, which provides a practical framework for implementing the Web of Things. We very much appreciate our collaboration with the W3C, and we look forward to expanding this collaboration. At ITU, we believe that facilitating global learning and meaningful collaboration are key to enhance our knowledge and understanding of the latest trends in digital transformation. That is exactly our aim today, and we can look forward to expert insights on the key features and the functions of the Web of Things, as well as some use cases highlighting its applicability in the smart city and IoT context. Let me also take this opportunity to remind everyone that the fourth ITU Global Standards Symposium called GSS will take place on the 28th of February this year, followed by the governing conference of ITU's standardization sector called the World Telecommunication Standard Assembly from the 1st to 9th of March. The participation in GSS is open to everyone, so I encourage you to join us to discuss the role of international standards in enabling digital transformation and achieving the sustainable development goals. I know this ahead, so let me now pass the floor to our moderator. Thank you very much. All the best.
Thank you, Dr. Lee. So once again, welcome to all our participants. So before we delve into today's discussion, please take note of how the session will be run. So after all the presentations, we will have the Q&A portion, but please feel free to type in your questions via the Q&A icon even before the Q&A portion. So kindly note that the recording and all the presentations will be made available on the event webpage. And also closed captioning is available for this event, so you may turn it on by enabling the closed captioning icon. So before we start, of course, we would like to take this opportunity to thank Dr. Gyumong Lee and Dr. Makul for their hard work and efforts to put this program together. So we have an excellent list of panelists for today's discussion. So I would like to call on Dr. Rami Ahmed Fati, Vice Chairman of ITUT Study Group 20 and the Director of Digital Services Planning and Risk Assessment of the National Telecom Regulatory Authority. Dr. Rami, the floor is yours.
Thank you very much, Chiara, and welcome everyone on this very interesting webinar. It's indeed one of the most important topics that we address or plan to address here today. And we have a distinguished list of experts on board from the ITU and from the WCC and from China as well. So my name is Rami Ahmed Fathi. I'm the Vice Chairman of the ITUT Study Group 20 at the ITU. And I serve as the Executive Director of Digital Services and QoS at the Egyptian Telecom Regulator. It's my pleasure to be here and to be chairing and moderating this session. In this session, we will focus on the Web of Things from the architectural point of view. More specifically, we will look at the basic conceptual framework of Web of Things, their specifications and requirements, as well as several use cases to help us deep dive into this very interesting topic. We are planning to finalize the webinar by 4:55 p.m. CET. We have 5 distinguished experts, so I kindly appreciate from the speakers to limit their presentation to 15 minutes each. This will give us plenty of time, sufficient time, hopefully, for a very interesting Q&A section at the end of this webinar. So without further delay, allow me to welcome our first speaker, Gyumong Lee. Gyumong Lee is a professor at Liverpool John Moores University at the UK. He's also the rapporteur of Q4 20, which handles standardization, many standardization aspects in the ITU. So I'll give a very brief introduction on Dr. Lee. Dr. Lee, prior to joining Liverpool John Moores University, he has worked with the Institut Mines Telecom Sud Paris, France from 2008 until 2012. He had been invited to work with ETRI, that's the Electronics and Telecommunications Research Institute in Korea. He also worked as a research professor in KAIST, Korea, and as a guest researcher in National Institute of Standards and Technology in the United States in 2007. His research interests include Internet of Things, data analytics, computational trust, knowledge-centric networking and services, and a bunch more of very interesting stuff. So Dr. Lee, Gyumong, I'll pass the floor to you, over to you.
Thank you. So I would like to introduce the key result of WOT standardization in ITUT. So as you can see on the screen, the title of today's talk is Standardization and the Challenges. So before starting, actually the director of ITUT, Joseph Lee, he indicated about 10 years before we already started relevant standardization activities on WOT. So I would like to briefly provide all the details of individual items. And then mostly important aspect is how we well consider these kind of important topics in the future. So as a potential work items, I would like to also illustrate various kind of important aspects. And then we are currently doing a joint webinar with the W3C. So in this regard, I would like to also find a good opportunity to collaborate with the W3C. So as you can see here in ITOT, there are several recommendations on WOT. So mostly some basic functions and some key component for implementations. So I would like to introduce the key ideas of WOT and then some related component. So when we firstly started WOT, so at the time, from the Internet of Things, we tried to consider to interconnect various kind of services via web technologies. So in this regard, so many number of services are also interconnected. So this is a kind of extension of a very conventional IoT technology. So in this regard, we have well identified various kind of important features by using web technologies. So in order to do that, we just simply thought about how we will interconnect various kind of important services via certain particular component. So such as some agent like broker, this is a really important element to interconnect various kind of devices. And then web technology provide us kind of good features for measure many different services as a composite manner. So this kind of manner, we identified this technology in a very basic level. And then we also considered to go into details for identifying relevant functional components. So for example, in here, as a service function, and in some case, service control function, and then resource management. So these are kind of core functionality for interacting with the web client. And then we also well identified various kind of functions for resource related aspect with the devices here. So that kind of manner we also well thought about various kind of important elements considering composition aspects. So for example, in here, there are many different types of objects. So this kind of object can be composite together. So then virtual composite object. So this is a really important element how we well consider various kind of newly generated services. So this kind of manner we have identified relevant service components, specifically providing quite hierarchical architectural views. And then one of the important element for services, some particular use case, we firstly considered home environment. So as you can see here, there are lots of devices in a home environment. So then virtual home network is one of the important consideration areas. So basically, when we consider this home environment, so we will identify the two aspects. So part one is object processing functions directly with relevant interfaces considering so many different types of devices. And secondly, how we interact with the applications. So this one is related to service supporting functionalities. Similarly, we also considered various kind of new application areas. So one identified application is healthcare areas, particularly interoperability point of view. Apart from very generic level interoperable solutions, we are thinking about various different types of interoperability aspects, such as a syntactic level and semantic levels together. So that kind of manner we are currently working on various kind of new features So this document is still developing in ITUT Study Group 20. Apart from this kind of a document in ITUT, so currently we also have several recommendations which are related to WOT. For example, semantic-based requirement, things description, and then recently we also considered a web-based data model. So as you can see here, in case of a semantics-based requirement, so we have a well-considered various kind of essential requirements, such as interoperability, scalability, various kind of key items considering semantics. Mostly important aspect is such as ontology and semantic annotation, semantic interoperability, and discovery and reasoning aspect together. Another important thing is things description. So we are currently working on various kind of different level of things, like physical things and virtual things. Some cases these kind of things need to be modeled as a various kind of different aspects. So then quite important thing is how we well present physical environment into virtual environment. So then quite the essential point is representation of a physical entity. So things description is a really important element to correctly model physical world into information world here. And then very interesting point is that last year, ITUT Study Group 20, we also developed one supplement. So this one is web-based data model. So in here, based on very conventional concept of metadata, here are various kind of different meanings of different types of metadata. We also newly identified procedural metadata here. So this metadata is relatively a new concept. So more interactively, we are providing various kind of useful information for dynamically interacting many different types of things. So this document provides this kind of essential component and then relevant key items. Actually, this kind of works are really a list of all relevant activities in WOT in ITUT. So actually, I also would like to provide you some other relevant work. For example, as you can see in here, last year we well collaborated with IEEE in order to consider a new initiative. So this one is related to urban intelligence. So in case of a global observatory for urban intelligence, there are lots of important considerations. Particularly, we really wanted to well understand cities. And then another thing is how we well communicate and then utilize this kind of city infrastructures into our ICT domain. So when we well analyze this kind of key demand and some particular requirement, so we came up certain particular ideas. So how we really provide kind of good environment with various kind of tools. So we have identified three important elements. So first one is smart cities ontologies as a common language. So as you can see in here. And secondly, we also well identified the necessity of semantics, so more concrete ways for providing various kind of meaningful information. And then lastly, digital twins is also very important considerations. So in order to well model various kind of different cities environments, simulation, monitoring, and analyzing and reporting various kind of predicting these kind of whole features can be provided by digital twins. So in this regard, currently we are working on various kind of similar areas in ITUT, I believe these kind of solutions are also tightly linked with the web technologies. And then lastly, I would like to also emphasize various kind of important points. So as a challenges, definitely we need to well consider new obligations based on web technology. Instead of just considering conventional web, currently there are lots of demand to cover quite decentralized service environment. So that kind of evolution of web technology is also one of the challenging areas. So in order to successfully consider this kind of quite interesting topics, we also need to well collaborate with the relevant standardization bodies. Particularly W3C is really core bodies for standardization on web technologies. So in this regard, we really wanted to well think about how we maximize the relevant synergy through the collaboration between ITUT and the W3C. So that's all the details of my presentation. Thank you.
Thank you very much. Thank you very much, Dr. Lee, for an excellent presentation and for sharing with us the progress of the ITU and the recent updates happening in the ITU in this important domain as well. So our next speaker is Michael McCool, Dr. Michael McCool, who's also the co-chair of W3C Web of Things. A very short introduction to his bio, a very rich bio as well. Dr. Michael McCool, the Intel principal engineer, he has experience in a wide range of areas from computer graphics to high performance computing to robotics to IoT. He has been both a university professor and a successful entrepreneur. His venture RapidMind was acquired by Intel in 2009. Currently, he's working on robotics and Internet of Things, including programming environments, system for real-time and embedded HPC software, accelerated computing for HPC and AI, edge computing and IoT metadata and semantics. Most recently has been co-chairing the W3C WOT working group, developing the W3C Web of Things standard, which supports portable metadata for IoT devices, describing their services and their network interfaces. So without further delay, I'm passing the floor to you, Michael. Over to you.
Thank you very much, Rami. And I'm going to dive right into the presentation. So I'm going to be talking about primarily the W3C approach of things, but I want to position this relative to other WOT concepts and discussion, because the concept is broader than that, and then I'll focus on the standardization activity within W3C. So I'm going to first talk about kind of the definitions of what WOT is, and then about the particular things that we're doing within W3C. I'll then shift over to talk about some applications and some use cases. And in addition to smart cities, I'm also going to talk about smart buildings and kind of some adjacent use cases to smart cities. I'm going to finish up with a set of gaps. And as I'll mention, we're trying to avoid creating yet another isolated silo. What we're trying to do is fill in the gaps in existing standards and make everything work well together. So I think at the end there, I want to identify some additional gaps that we found as we work through our standards work. So the general idea of WOT, as I see it, is we're adapting web technologies, which is a very successful set of standards, to the IoT. So how can we take the successful model that's used for web applications, web services, browsers, et cetera, and deploy that or integrate with it or extend it or model it in the IoT? And we want to have similar ability for interoperability and scalability. I think also we want to be able to use existing web services within IoT applications in a convenient way. And as I said, we really want to avoid creating more fragmentation. So the last thing we want to do is create yet another vertical silo that doesn't interoperate with other things. Instead, there's already a wide variety of IoT standards. And can we find ways from the work there?
Sorry to interject, but we don't see
Yeah.
your presentation. Should we share for you? We don't see your presentation.
Really? Hold me a second.
Yes.
We'll fix that. I forgot to click share screen. My apologies. And we'll start again. Start again. Okay. Well, you didn't miss much. I was still on this slide. So, right, the definition of what? And again, we don't want to create yet another vertical silo. Instead, we have these large number of existing standards, and can we make them work better together and work better with the web? And so one of the gaps we identified many years ago was there was no consistent way to describe the interface, no consistent abstraction for how to talk to IoT devices or services. So one of the things that we worked on, which has already been published, is a metadata format, which also standardizes a common abstraction. And the overall goal to achieve interoperability is to have this idea of a narrow waist. Now, in the internet world, the narrow waist is a protocol, IP. The trouble is that ship has sailed in IoT. There's already dozens of protocols. It's really hard to get everybody to agree on one. It's also not clear that one protocol can satisfy all the various requirements of devices. So instead, we thought we'd focus on a common abstraction layer as the narrow waist for achieving interoperability. And we fiddle in this abstraction based around entities like properties, actions, and events that are common across protocols. And the idea is you can write applications against this abstraction, and the abstractions are then mapped back to the concrete implementation in a certain protocol. And the thing description, which we'll have a longer discussion from Sebastian on, is this metadata format that describes how the protocol maps into the abstraction. And what particular properties, events, and actions that a particular device exposes. Now, in addition to protocols, there's also security standards, many of them. There's data payload standards, many of them. And so they also describe things like data schemas and security requirements for devices. So that's done. Now, it's still a work in progress, and there's also other gaps in metadata like geolocation that I'll get to later on. But right now, we describe the network interface, its security, and its payload format. Now, the additional gap we're working right now is, okay, how do I get this metadata for a given device? And so we're working on standards to discover thing descriptions for devices and services so you can connect to them in an easy way. So that's in flight. And I'm going to now talk very briefly about TDs, given that Sebastian will be going in more detail. But basically, a thing is, an abstraction. It's an entity that has a network interface, a set of network affordances. We did have a few constraints. So we want to talk about protocols where there's URIs to identify endpoints. And we also want to use existing standards like INA, media types, and so forth. But the basic idea is we have this set of affordances, like a property, an event, or an action. The affordance describes what the choices are, but the user of these affordances doesn't have to worry about how it actually is implemented. The idea is that an automatic system can use the metadata to implement the execution of the affordance. So you can just read a property. You don't have to worry about the fact that you have to do a get method on HTTP or whatever. That's taken care of automatically. So the idea is to simplify and unify how you interact with various IoT services. And again, this is descriptive. So we're prescribing the format of metadata, but we're not prescribing the protocols. We're not prescribing certain URL hierarchies, for example. So instead, we're describing how a given device works. And then the reader of the TD can read the description and figure out how to talk to the device. And I will say that we also are quite broad in kind of usage applications. There's various places and ways in which TDs can be used. It could be used for peer-to-peer connection between devices. It could be used for reading devices into a hub and re-exposing new interfaces that, for example, map from one protocol to another. It could be used for proxies to map from one network location to another. It could be used for cloud services, providing various things. It could be used for edge services, providing various things. It could be read by a browser to generate a user interface for talking to a set of things on a network. So there are lots of existing applications for thing descriptions, and we're trying to include the right features to include a set of applications like this. I will say, in addition, there's the issue of orchestration, or perhaps it could be better termed automation. So very often, you're going to be building new services by integrating existing things and having them interoperate in certain ways. So when a certain event happens, maybe you want something else to happen. So you want to have some way to glue things together. So these may even derive new virtual things that expose a new interface to interact with that kind of collection of devices or functionality. So we've been exploring various ways to do this using both scripting languages and using visual languages. However, I think this is one of the gaps that we need to talk about, is how exactly should automation work? Should it be an automation rule engine with its own language, or should it be APIs that integrate with existing systems? I think this is still an open question, but we have definitely experimented with this. For discovery, one of the key issues is privacy and security. So basically, we want to share metadata about things, but also control how it is shared. So it's shared to the right people and in the right contexts. And so one of the challenges is that past discovery mechanisms that try to include both discovery and sharing in one step ended up becoming obsolete over time, and then have security holes exposed. And so we wanted to avoid that. There's also was the case, there's a lot of existing discovery mechanisms, which while they were out there, they weren't necessarily had the best security. So we decided to propose a two-phase strategy where we use existing discovery mechanisms to just get a URL. And then from that URL, we access an exploration service that actually serves the metadata. And the idea is that anything that gives you a URL can be used as introduction or a first contact protocol, but no metadata is shared in that first phase, just the URL. And then from there, you then authenticate with an exploration service, confirm you have the rights to the metadata, and then you can do powerful mechanisms to search for metadata. One of the gaps we currently have is tying this into geolocation. So you might want to discover things in a location. We're not currently doing that, but it is definitely one of the things that's on the table as a thing to look at in the future. We also want to support a query language, and right now there's kind of 3 candidates, but none of them are perfect, and none of them are quite in the state where we can adopt them wholeheartedly. So I think that in the future, we're going to be elaborating upon the mechanism to query large sets of thing descriptions and devices, which I think is also important for Smart City. Okay. Now, the W3C, of course, is responsible for many of the standards around the web. And it's also responsible for many of the standards, especially in the browser. So we are, interoperating with those set of standards, but we also have a set of normative documents that we are working on or we have published. So there's a general architecture document, and then the thing description itself, and also some new things in flight right now for discovery, and actually profiles, which kind of narrow the scope of a thing description to a particular application or category of applications. There's also binding templates, which talk about how you connect to a certain protocol. So maybe you want to do HTTP, how do you do that exactly? And this describes how to use a thing description for a certain use case. Scripting is experimental, again, the orchestration issue, but we do have an API for talking to it from JavaScript. And then we also have a large document that describes many different use cases, which we're using to extract requirements. Anyways, you want to find all these things later on. The thing you have to remember is the website at the bottom, and it's all linked from there. So we also have, I want to mention some recent activity. So we have a bunch of events. We have Plug Fests where we test things out. And also, I'm going to briefly in a minute just talk about some commercial usages, talk about some applications. And also for W3C requires implementation of any standard. And so for the new things, directories, there are actually 3 standards a couple of which are in fact open source. We also collaborate closely with IETF, and I will say for geospatial data going forward, the Open Geospatial Consortium is also an important partner for that kind of future work. Right, and we're currently, wrapping up our current charter, and we're now looking at defining what to do next. And so it's a good opportunity for us to discuss what gaps exist and what needs to be done next. So regarding use cases, I just want to briefly describe our process. We want to define the requirements for work and what it really needs to be done. And so we look at the verticals, maybe agriculture, maybe retail applications, maybe smart building management. And then we look at horizontal requirements. So maybe I need edge computing, maybe I need a way to authenticate and manage keys in a private network, that sort of thing. And then from there, we need to also then define requirements. What are the gaps? What do we need to do? And again, while avoiding duplicating existing work or conflicting with other things that already exist and are in common usage. And so there's a process, and we encourage people to engage with us if they have a use case or they want to contribute something that we should be considering for future work. Now I've extracted a list of some of the use cases that I think are relevant to smart cities that are currently discussed in our documents. So things directly related to smart city, like geolocation, IoT dashboards. Maybe I have a museum and I want to be able to display things to people as they walk around. Maybe I want to track COVID infections and have vaccine passports, something like this. Public health monitoring. Maybe I want to have distributed energy resources. So it's not exactly just a smart city thing. The other thing I want to say is I think we don't want to be too narrowly focused on one vertical. So things like geolocation also apply to agriculture, transportation, logistics. And it would be unfortunate to have one geolocation standard for cities and one for other things, because then we have silos again. So we do need to think about what are the common features across verticals, and can we solve some narrow piece in a way that works for everybody. We've also got a good association with a retail organization in the US, and we are discussing many retail applications. I think these are also quite relevant to smart city because the commercial life in the city is important, and you can imagine things like distributed energy or health monitoring being impacting retail as well as part of the city. And finally, building information systems have been one key application area. And I'm just going to flip over to this slide because Takanaka Corporation in Japan has built a quite interesting BIM system using watt metadata. And also Siemens has a system, which I'm sure Sebastian will touch on, that is also using watt for building information management. And one of the key problems with buildings is they do transfer ownership, and you need to understand how a BIM works when you get a new building. So you need to be able to have good documentation and good understanding of how the system works. So it's important to have a standard way to describe how the system works and how to operate with it. And going forward, things like distributed energy and buildings generating their own data and managing energy are also going to be important, which requires integration with the grid and other things. There's also a new company out of Munich, which is looking at supporting dashboards based on hubs, which is NETS. So there's several things coming up now that are adopting the W3C standard for real systems. So I just want to finish up with a list of gaps as I see them. We are currently, of course, collecting this as part of this whole process. I've focused on gaps that I think are relevant to the smart city. So I think that GIS integration is top of my list. Smart cities often need to talk about where things are, and you often have to deal with things like property, routing of pipes, and so forth, and sensor locations. And so you're often integrating things with IoT data in geospatial context. And there's many existing standards for geospatial information. We need to figure out, which standard to adopt and how to integrate them into watt systems. And it's actually both where things are and also the data they return might be location oriented. You can also have moving devices like vehicles and robots, and that needs to be dealt with as well. Kind of related to geospatial data is actually temporal data. And there's some IEEE activity going on about how to manage data, how to query temporal databases, and so forth. Historical data is also very important. In general, data management is a big topic, which we haven't touched on yet in our W3C efforts. But who manages data, the privacy of it, how you get notified of changes in data, how you manage historical data, all that stuff. Digital twins, how you have devices that are offline, but you have shadow copies of them, all that stuff. Security is another huge problem, especially segmented networks. So it's very often an IoT device is on a network and the IoT devices are not visible globally. And you maybe don't want them to be. But it turns out this kind of breaks the browser model of CA certificate management. And so we need to clean that up to truly get connected into the browser world and web services. We, again, have some vertical use cases, transportation logistics, DER, that are kind of adjacent or part of the smart city. So I'm going to stop there and let the next guest present.
I was muted. Thank you. Thank you very much, Michael, for the excellent presentation indeed, and very informative topics. And you touched upon very important aspects, in particular the gaps present out there. If there's time, definitely, I presume there would be definitely questions on these particular important elements as well. So the next speaker that we have on board is Kazuyuki Ashimura. Dr. Kaz is the project professor of Keio University and the W3C Web of Things team contact. Dr. Kaz joined the W3C team at Keio University SFC in April 2005. Prior to joining the team, Kaz worked for 12 years on research and development on speech and natural language processing. He has been working on web standardization related to voice, multimodal, web and TV, automotive geolocation, NFC, WOT, and smart cities since he joined W3C 17 years ago. He's interested in applying the web technologies to everyday lives and would like to make people happy using the web standards. Kaz received his BS in mathematics from Kyoto University and his Doctor of Engineering degree from Nara Institute of Science and Technology.
Hello?
Yes, Kaz, did you?
Yeah, actually, I couldn't hear you for a while. So anyway, may I start?
Then allow me to repeat. Allow me to repeat very quickly. So I was saying a very quick introduction for you, project professor, Keio University, and yes, W3C Web of Things team contact.
Yeah,
over to you, sir.
Okay, and only the last 10 seconds.
Okay.
But I'm okay. So let me share my screen first then. And then let me make this presentation mode. Okay, so let me start. I will talk about 4 points today. Web technology for various industries, web standardization by W3C very quickly, and then WT also quickly, and then finally smart cities. So as you know, web technology is available and used popularly everywhere these days, not only your PC, smartphones, but also TV devices, IVI devices, ebooks, and so on. And web technology actually includes various technologies like this. And yeah, familiar examples of HTML5, for example, includes video audio capability and duplex network connection and so on. And so you can now enjoy Google, Amazon, Facebook, Netflix, and so on. And originally, web technology was mainly used for home page distribution, but now this is this important and flexible platform for data handling in general. And yes, so various web technologies and web standards on the left side used for various services on the right side. For example, TV broadcasting and also digital publishing. And these days, connected cars, meaning IVI system within the car, they are connecting with cloud services. And also these days, IoT, and as Michael McCool mentioned, and also Sebastian will mention, WT is very useful. And yes, let me describe W3C as a whole very quickly. Yeah, basically, W3C was established by Tim Berners-Lee, who invented the web system himself in 1994. And actually, this organization is run by 4 research organizations: MIT in United States, LSM in France, and Keio University in Japan, and also Beihai University in China, collaboratively. And the key point here is, like the internet, web is also just one entity, one network all over the world. And so interoperability, multilinguality, multimodality, accessibility, and so on are very important for everybody. Yeah. And now we have around 460 organizations as WCC members, and yeah, various countries and various industries. And then the standardization work is done mainly by the working groups, and WCC recommendations published by these groups, so 43 working groups. And interest groups, business groups working on business needs and use cases and so on, mainly. And the committee groups can work on any kind of technologies related to the web. And the key point here is interest groups, business groups, committee groups working on use cases from various industries like TV, publishing, connected car, smart homes, smart cities, retail, and so on. And the working group will generate actual standards one by one based on their use cases. And web of things, yeah, Michael McCool already talked about the detail, and Sebastian will talk about the detail of the sync description specification. But please let me explain the brief idea. So there are problems of IoT silos, meaning various companies working very hard on their own implementations. And there's a big gap between interoperability. Yeah. And we would like to improve the situation by web standards and like this. So any kind of applications generated by any kind of companies can be connected with various devices from various companies based on this mechanism. And this is kind of like this kind of AC adapter, yeah, for global purposes. And the key technology is sync description, and Sebastian will describe this in detail later. Yeah, and expected use cases should include multi-vendor integration this time for WT version 1.1 this year. And should include various industry needs: television, publishing, connected cars, smart homes, smart cities, and so on, and clarified as requirements for actual standards. And we are working on vertical industry needs and also horizontal common use cases as basic requirements. And as Michael also mentioned, yeah, there are several, yeah, actually many use cases from vertical industries like TV industry, smart agriculture, smart building, smart city, and so on. And we are also clarifying the requirements based on those use cases. And for example, digital twins multi-protocol integration, big data handling, lifecycle management, and so on. And so we work on this kind of cycle for standardization use case, and then clarify requirements for technology and see the gap with existing standards, and then actual standardization by generating W3C recommendation documents, and try to implement the specifications and ask all the people from the world to implement and deploy the technology, and then version 2, version 3, version 4. Yeah, and this is rather my personal opinion or target, but there are actually several, many more W3 standards within W3C working groups, and named the decentralized identifier (DID) and verified credential (BC) in addition to WT, and these guys can be used to identify both the hardware devices and users, and also, all the information is managed by encrypted manners, and so safely handled, and the security and privacy can be obtained. Yeah, and then finally, I'd like to talk about the smart cities work within W3C. So, as you know, so there are so many stakeholders for smart city discussion. So governments, countries, projects, standards organizations, and so on. And so many existing smart cities all over the world already. And so we need to standardize what is really needed and what should be done, and the concrete data model, and how to handle the data model, and the vocabulary for that purpose, and so on. So W3C also started to discuss this topic, and actually based on the use case discussion from the WT working group, and they had dedicated international workshop last year, and clarified who should be the stakeholders for this topic, and also reasonable applications, expectations, and also tried to generate a possible charter, meaning planning document for possible discussion group like this. And this is a list of the participants in that workshop, and the topics included, for example, use cases, and various participants from all over the world, including China, England, United States, Japan, participated and provided the ideas from various industries. And also existing standards, Jerome mentioned the E-class ontology for smart city purposes, and Clarissa mentioned the Brazilian governmental project for smart cities based on IQT standards, and also web-based approach. Actually, Sebastian and Michael both provided the ideas based on WT standards, and Jacqueline, Dave Markov also gave ideas based on their own activities, like ontologies. And also cross-cutting issues like accessibility and privacy management, and user interface improvement, and so on. And I myself also mentioned data governance for smart cities. And standardization work has started within W3C for smart cities as well. And please note that, so there is some criticism about the smart cities activity itself. For example, high-level big data collection by the government. That is kind of dangerous, that's true. So we need to think about how to handle the data from you and myself and everybody. So data transfer from ourselves to the government, and how to handle the data, probably by the infrastructure vendors or other service vendors. And so we need to clarify the data transfer and how to improve the data management and privacy management and so on. So we need a dedicated discussion group for this purpose as well. And please remember what is really important for this topic. Yeah, there are so many stakeholders: government, content producers, network providers, system developers, hardware vendors, infrastructure providers, service providers. Yeah, of course, everybody is important. However, the most important part should be ourselves, the users. Yeah, so we would like to work with the existing standards organizations, including IQT, yeah, to clarify our needs and how to deal with data governance and so on, collaboratively. Yeah, that's it. Thank you.
Thank you very much, Gaz, for the excellent presentation. Thank you. And now for the next speaker in line, we have Sebastian Kibisch. Dr. Sebastian is a senior key expert at Siemens Technology in Munich, Germany. His work focuses on the efficient realization and usage of standardized internet and web technologies for the industrial Internet of Things domain. He drives strategic initiatives, research and development for Siemens business units, such as industrial and building automation. Sebastian is also an active member and a contributor to the standardization groups such as E-Class Industrial Digital Twin Association, WCC Web of Things as well. In the later, he's also the co-chair and of this group and coordinates the topics around WCC thing description. In that context, Sebastian is one of the initiators and authors of numerous reference implementations for the Web of Things standardization activities as well. To name some, we have, for example, Eclipse, Node, WOT, and the things description authoring tool called Eclipse Editor. Hope I got that right. And now over to you, Sebastian.
Thank you very much. And thank you for the nice introduction. And I say also hello to everyone who is here in the webinar. And I will set up my presentation, and I hope you can see everything in the right way. So, yeah, my talk is about to give you some insight about, I would say, this key technology of Web of Things that is called the thing description. And before I'm going to do that, I would like also to say which kind of application area this will be applied to. And since our context is smart city in this webinar, I will try to bring this also in that context. And the first thing is what we have in typical setup in smart cities, and we have there also this, in a very abstract manner, different kind of things there. Yeah, we have buildings there. We have some things that coming from some private sector, like some e-scooter systems or rental systems, or we have some electrical vehicles and so on. And of course, we have also the stuff which is coming from the public domain, like the coordination of the traffics and coordination of the traffic signals and so on. And we have the public transportation and so on. And what is also kind of important and getting more important is to rely on your application that is also using more and more this renewable energy systems or energy for your system that you like to run to. And the question is always, when you try to develop application with this different kind of things, which can be different kind of purposes, like for monitoring, controlling, or for AI stuff, cloud services, or you want to like to provide services, commercial service, and so on, then you have always to come to the situation, how can I get the data and all the functionality that the different kind of things that you have in the smart cities, how you can access to. And the very big problem is that this different kind of heterogeneous things have different kind of interfaces in terms of how does the protocol look like that they're using, how the data model looks like, and so on. And this is something what is a very big problem in IoT systems or IoT application, that you have always to face the situation that you have to understand what the different IoT things will offer you and how to use it and so on. And this is typical, which costs a lot of money and cost of effort to invest in your application, and this is one of the major tasks which we like to challenge with Web of Things, to reduce the integration costs and reduce also the investigation in develop application or IoT applications. And this is where we are like to apply Web of Things here. So as already introduced by Michael McCool, is that we are having building blocks that we have, or that we call this kind of thing description. And the thing description is, to say in a simple word, like the index HTML or the web page of the thing, so like a landing page of the thing, and provides you an entry point to understand what the thing is offering you. And this is then the opportunity to rely on this kind of unified description, and helps you then to develop the application for your purposes. And another building block what we have in Web of Things is this abstraction property action events. So this is also a very cool way where you can simply rely on this pattern or affordances to develop your application then for your IoT scenario. And now I would like to go to the thing description to give you a more understanding what is the thing description about, and why is this a great thing to use it in your IoT application to reduce the cost in implementation and reduce the IoT integration efforts and so on. And I would like to give you some more understanding what we're doing there in the thing description. And before I go in that detail, I would like to make a comparison here. I think everyone knows what a web page is, and typical when you go to a web page, and I have here an example from my university, which I'm also teaching lessons like the Web of Things as example. I'm sorry that it's everything in German, but it doesn't matter because many people already understand at least the context and how the structure look like and what I have to do here. So, and first of thing, what you will identify here, that you're in the very beginning, there's the context of this web page. So you already can guessing it has something to do with university here. And then you're getting some detailed information about something, what you can do here. And you also know I have to click somewhere to get more information. And on the very top, you see also this form field where you have to enter something and where you can click then on something. And what you can also see here is that you can use this field here to select some information and so on. And yeah, and this is, I think, a very nice example, and which we don't think anymore. Yeah, we're going to any web page, getting some information, we know where to click to and where to get more information. And the cool thing, this works very well independently which devices you're using. If you're using your mobile phone, your web browser on your laptop or on tablet and so on, this works very smoothly. And the reason why it's working smoothly is there are standards behind it. There are standards, for example, the HTML provided by W3C and so on. And this is a very cool thing that works very well. However, now I would like to go to the things, yeah, to our assets, which we have to consider in our smart city scenario, and how does it work there? So how we understand what the things is offering and how I can bring these things in my IoT system. And typical engineers have to ask different kind of questions for doing so. Yeah, so the typical asking, yeah, who are you? Are you a kind of a sensor, or you're kind of a actuator, and what is your brand name, and what serial number you have, and so on. So there are some basic information you require. Then typical, you would understand what is the context there. What kind of function do you have? What kind of data do you serve? And then, of course, how does your data look like? How will your payload structure look like? And then it's kind of very important to understand how can I access this data and function if I'm really interested into it. Yeah. And yeah, and then of course I need also to understand what protocol is used and how the serialization look like, and is there some security constraints which I have to fulfill. And sometimes it's also very important to understand if there are some dependencies to other things. Well, and typical that kind of information, and to answer this question is, yeah, I would say state of the art in that way, that you have to look up in user manuals. Yeah, you buy IoT equipment as example, and or you have to go to a web page where typical some information is provided, and then you have to do some manual work there to understand how to use this thing for your applications. And this is what is very expensive and takes a long time, and is also very error prone, because you quickly mix up some settings and do some wrong copy paste in different places, and then you maybe find out in a very late stage in your development that something's wrong here, and then you have to discover the problem here. Well, and now the thing description comes into the play here, and this is what we like to offer here to the additional to the thing, yeah, that we're having this kind of landing page of the thing to understand, yeah, what is offered here by this thing, and gives you all the answers of this question that is showing up here. So the thing description itself is defined as in JSON LD. This is a JSON-based format, however, provides you also the opportunity to rely on RDF semantics. So that means you can also integrate existing ontologies, which already existing there. So if you have already, I don't know, semantics, for example, from Zaref or the schema.org, which is also very popular, then you can simply rely on this, and we use this in the thing description to enrich the thing description with this information of the thing that is rely on a specific technology. And I think this is also a topic, Mr. Lee also mentioned this on the beginning in the presentation. Yeah, we need also this smart city ontology. And this is then would be perfectly work together with thing description, because thing description is designed to, in that way to reuse or to integrate ontologies. And if we have smart city ontologies, then we can simply also integrate this in thing description then. Well, and here are some examples how a thing description look like. So as I mentioned, we have this JSON-based format. However, it's a very special JSON format, namely in JSON LD. This has some own keywords which you have to use to provide information in which context you are relying on, and we define for the thing description our own context, which has this this namespace here. And if you like, as already mentioned, you can also integrate other contexts in addition to provide additional semantic information here. Yeah, and then you can set up some basic information like providing ID, giving a title, providing some security information. So this is also very important to understand, that you can announce in the thing description on which security mechanism you're relying on. And don't worry, this is not the details where you put in password or any certificates or something like that. No, it's just a hint for the consumer that he knows what kind of mechanism he has to do. And in the case of OAuth example, he getting also the information where he have to go to, for example, getting a token for the communication then. Yeah. So this is more or less the metadata to provide the information to consumer how the security mechanism have to follow for the specific thing. Well, and then it starts to define all your property action events. And in that case, we have a property here, which providing a value. It would be this temperature value, and gives you some metadata about the data value which is exchanged. And the cool thing is that we're here using existing terms from JSON schema. So JSON schema is also a very popular schema technology to define JSON schema, JSON documents, and we're simply relying on that. And that also means you can reuse existing JSON schema tools to make your validation of your data types. And this is what I also missed to mention, and is that we are, as I would say, we not invented so much new in the thing description. We just put a lot of existing standards in there. So we're relying on JSON LD, we're using JSON schema approach, and providing a way how to use existing security mechanism and so on. So this is what we are doing here, and yeah, and how we're going to define this. And I think what is also important to understand is that thing description can also be used for, I would say, legacy devices, so devices which have, for example, I would say protocols used which are not that common anymore, or maybe used in more in other domains or in special domains. So like Modbus protocol and so on. And the cool thing, if you have such kind of device, then still the thing description can be used to describe this kind of special device with such legacy protocols, to bring in such devices also in the new, I would say, web domain or web ecosystem, and to work with them in your IoT application. And yeah, and the interesting part is the forms field is be used, and maybe to give you answer why we are named this as a forms, and maybe coming back to the web page where we have also this form field here in the very beginning. And here's the same idea. Yeah, so the thing typical also send the data which typical have in the memory, put the value what he has from the memory in a message and send to a client, right? And this is the same approach what is also happening here in the web page. You enter some data. In the background, the data is taken into some specific message and is sent to the backend. And this is the reason why we're using the same term here, the forms, or which coming from the web forms. And the cool thing is that the thing description is protocol agnostic. We're supporting any kind of well-known protocols like HTTP, MQTT, CoAP, and so on. As you can see, dependent on what protocol you're using, special settings have to be provided here. So for HTTP, you have to use a specific resource, and then you have to provide which operation you're going to apply on this resource. And for MQTT, you have different operations here. However, the pattern or this framework where you put this communication metadata is always the same and is then there's just a variation depending on the protocol using. And yeah, and we can also use some protocols that maybe are used more in the industry environment or like in building system or in manufacturing. So like Modbus, OPC-UA or MBus and so on. So there's many more possible to apply here and to use to define your thing based on the specific protocol that you have there. Well, and I just want to complete more or less my presentation to show we have already some tools which you can use to start to play with creating thing description. So the editor is, for example, a project which helps you to design thing description without reading the specification document. So it's a kind of a assistant there which asking you what is the name of your thing and how many properties do you like to have and so on. So it's a nice way where you can click your thing description or valid thing description in a very easy way without studying the specification document and looking for the details. So the editor is doing the job for you and you can simple design thing description very easily for you. Well, and there are plenty more tools. So we have this web page, which already was also mentioned by Michael McCool's presentation. And we have also a developer space there. And as you can see, there are already plenty of tools and developer environments where you can develop your Web of Things application. So we have one reference implementation, which is also recommended by the WWDC because in there you will find always the latest feature implementation, what we are currently discuss in the WWDC. So it's called the Eclipse Thing Web Node WOT project. And if you go there, then you have also already had plenty of support of different protocols. And so this is what can recommend, and there's also plenty more tools and discovery tools for implemented directories and so on. So all the details you can find here on the web page from the Web of Things. Well, that's my last slide, and yeah, I'm looking forward for the question later.
Thank you, Sebastian, for an excellent overview and a deep technical dive of the specifications provided by the WCC. And now for our last speaker, Long from China Mobile. And right after that, we will directly go ahead with the Q&A session. So Rong got her MS degree from Beijing Institute of Technology University in 2006. She then joined Motorola China and Microsoft China as a software engineer, respectively, working in software and systems architecture. In 2013, she joined China Mobile as a member of Terminal R&D department. involved in research and standardization activities of rich communication suite and Wi-Fi display. In 2016, she joined IoT Technology and Application Research Department of CMCC, and she has been actively working for standardization related to IoT application protocol, IoT data model, and digital twin in ITUT, 1M2M, and CCSA. She's also the Vice Group Leader of Digital Twin Group of CCSA. So over to you, Ron.
Good morning, good afternoon, and good evening, everyone. I'm grateful for this opportunity to present in this webinar. In this presentation, I will share our understanding of Web of Things and how we put it into practice. With the rapid development of the Internet of Things business, the IoT devices has grown up to a huge number nowadays. And this fragment IoT needs to multiple interoperability problems between a variety protocols and semantics. First, because the data among different devices, different manufacturers, and even different models adopt different semantic state ambiguity is inevitable. Therefore, data analysis or parsing is difficult for user in our service. Second, from the perspective of management and operation, variety device requires different protocol in order to access the platform. The protocol docking and integration need to high development costs. Third, the cross-system service requires data from multiple systems or platform, but those data are isolated in the respective systems, which cause data sharing and interaction become complicated for users. Okay. So in response to such problems, we are trying to use the same model to resolve the difficulties that facing by IoT participants. The same model is a method that can abstract device functionality, and it is independent of protocol. When we design it, we hope it can help users acquire a common understanding of the details of capability, functionalities, and operations of the device. Moreover, these abstract data semantics are independent of the underlying protocol, so it can build cross-platform, cross-devices, and cross-systems device data semantics. This abstract model should also be simple enough so user and manufacturers can easily understand it. In addition, for convenience purpose, we think an SDK should be provided to improve the development process between devices and the platform. To achieve such a goal, we defined our theme model design principles according to the characteristics of Web of Things. First, the functionality and characteristics of the device should be abstract in this process. We mainly focus on the function modularization of the device and the interaction with others. Secondly, the SIM model needs to be flexible. The SIM model architecture, in addition to support the abstraction of the device itself, it also needs to build a connection with other devices and things. So the SIM model should support inheritance, modularization, and extensibility. Finally, I saw many speakers mentioned JSON. We also take JSON for our description language to describe the SIM model in our platform. It can. We think it can faster data verification when we development. By those principles, our system can provide unified and fast access capability. We will introduce more details in later slides. Now, let's take a look at how we construct the SIM model of the device. There are several steps required to complete our work, namely model abstraction, model description, and model instantiation. The first step is to abstract the IoT device data according to the SIM model abstract rules, which are independent of the protocol. And support abstract capability in different hierarchical levels. An example is shown in the figure. The second step is to employ the JSON descript language to describe and define the object. The third step is to instate the SIM model, which is to establish a virtual device on the platform based on the SIM model. Subsequent service can operate this virtual device according to the definition of the SIM model. So far, we have brought over 400 SIM model temperatures of IoT devices online, and over 1 million devices has adopted SIM model to interact with our platform. The SIM model has boosted our service quality and access capability, especially in the smart city and the home area. The solution of the SIM model standardize the data format between device and platforms, so data fragmentation and service barriers, greatly simplifies the development cost of device and application, and also provides a data foundation for the digital twin. For the implement of the SIM model on the platform side, we modified our IoT platform based on the unified data format of the SIM model, and transformed our IoT platform into a one-stop IoT development platform in a series of process such as unified device access, device management, device operation and monitoring, application development, value-added service, and unified capability gateway. And end-to-end complete connection is forged among IoT device, IoT platform, and IoT applications. In this connection, the SIM model serves as the data standard formats for both ends and provides a foundation for data value added service of industry applications. In later slides, we will give a specific example to explain how users can adopt the same model for a real service. Let's see how an actual smart firefighting system based on the same model is implemented. We know that firefighting is a typical fragmented IoT scenario that has a variety devices, variety platform, and variety users. All those different systems also involve variety subsystems, which cause isolation and fragmentation of data. So the dispatch system is unable to coordinate between them and provide efficiency guidelines for the firefighting service. In our implement of urban firefighting system, we have defined a standard scene model in the field of fire protecting, including different fire hydrants, smoking detectors, lights, cameras, and so on. Those devices data upstream to the respective management modules based on the unified data format defined by the same model. On the platform side, the unified same model interface is implemented for data interaction and rule connection to realize the unified presentation of the data of the security monitor system, public service system, and other systems. At the same time, different modules will provide a unified data interface based on the same model to different systems and applications, connecting security administrators, safety management departments, and other operators for integrated management of fire protection. In the actual operation process, there are three main tasks. The first is the device access process. The platform provides a scene model tool. The user just fill in the form in the platform based on the scene model. Then the platform will automatically generate the corresponding access SDK according to the user's input. It provides a different protocol for user to choose. After the user downloads the SDK to the device, the user only needs to simply update the config files and hook functions to complete the device access process. The second task is the remote testing process. Developer can perform virtual debugging on various functions of devices, such as data upstream and the device operations, which can improve the efficiency of R&D. The third part is application development, similar to the remote testing process. This can also be done based on the virtual devices. The virtual device is a train object provided by the platform according to the device abstraction. The developers can interact with the virtual device according to the unified data interface of the same model to complete the development of the application. So this whole process, we can see two advantages of the same model. One is the traditional device access debugging, application development serious process. has become a parallel process. Those 3 steps can be virtually operated on the platform based on the virtual device. This can greatly improve our development and deployment efficiency. From practice experience, the access time of our single IoT device has shortened from 3 or 4 weeks to about 1 week. Another advantage is the same model breaks what we so-called data island. All data now adopt standardized abstraction and description methods, so the data can flow freely among different systems and devices suitable for cross-systems scenarios such as smart city and smart firefighting. Finally, we would like to talk about our follow-up plans for the same model. From a technical perspective, we hope to integrate the same model with CPS, digital twin, and other cutting-edge technologies. For example, we can use the same model as the basic technologies and solution for device which enters in the IoT digital twin scenarios. From the application level, we will further update the same model standards, application tools, and provide service such as low-code development tools based on the same model. From the business perspective, in the future, we hope to derive more data value added applications as we can understand the data. From an ecological perspective, we're hoping to provide more device model temperatures at the same time, improve the certification and interoperability test capability of the same model to ensure data consistency. This is the end of my sharing. Thank you for listening.
Thank you very much. Thank you for the excellent presentation and for also respecting the time. Now to the long-awaited Q&A. We have several questions, and let me start directly by directing a question to Young. So we all know that emerging technologies like digital twins and decentralized web, in addition to data-related aspects for IoT and smart cities, are becoming, these days are becoming significantly important. Many governments and many actually companies are exploring these technologies. So in that context, what important areas or considerations for future standardization on Web of Things do you foresee, and how can we accommodate all these new emerging technologies in our standardization landscape?
Okay, so as you know, when we firstly considered Web of Things, at the time we just simply thought about how we interconnect various kinds of services by using web technology. So currently, there are lots of emerging technologies, such as digital twins, you already mentioned, and then decentralized webs, a new version of web technology. So these kind of technical solutions are commonly considered quite user-centric and user-driven approaches. So it means that there are lots of demand from the user side, and then there are also quite important elements to represent so many number of physical elements, such as humans or some particular physical entities, devices, sensors. So that kind of things can be represented as a certain particular descriptions. That's why we mentioned things description. So in this regard, for accommodating various kind of emerging solutions, so in case of IoT and various kind of smart city related services, we also need to think about how we link this kind of new solutions to the various kind of application areas in terms of some convenient and user-friendly interfaces. So rather than just considering various kind of underlying technologies, we also need to think about various kind of service and application aspects. So in this regard, WOT can be kind of good link between various kind of service supporting functions and application services. So that kind of manner, we need to dig into, go into details for various kind of more concrete solutions to link together so many number of elementary solutions. So that's my view for considering several new work items for future standardization.
Thank you, Yomyo. Maybe a follow-up question before going directly to Michael as well. How do you foresee, given what you have just mentioned, the importance of collaborating with W3C?
Yes, so W3C is dedicating to various kind of protocol development aspect. So, however, our ITOT perspective is we are mostly talking about somewhat generic use cases and requirements. Based on that kind of analysis, we are developing a kind of a framework document. So in order to really successfully deploy various kind of solutions, we also need to think about what kind of specific protocols need to be well developed in line with our approaches. So that's the reason why we need various kind of collaborations to map various kind of elements into so many types of protocols. So I believe that kind of things need to be considered with two different groups. So I think this is really awesome to work for collaboration.
Thank you, Gyumyong. Thank you very much for your presentation and for your contribution as well. So now over to Michael. I would like to shift the discussion quite a little bit on the gaps, and I would like to make use of one of your slides. You focused on the main gaps addressed by the W3C, and I was wondering if you can share with us, or at least lay a particular focus on one particular example of those identified gaps, which you think, in your opinion, is indeed extremely crucial for smart cities deployments. And in line of that question as well, I think also one of the participants of the webinar, Mr. Ajay Nair, also asked a question in that line, saying or asking, how do you see the dynamic 3D digital twin platforms integration? So that's an interesting question as well. So over to you.
Okay.
Michael.
So first thing to say is IoT is huge, okay? And I don't think any one standards organization or company can really deal with it all. And the trouble is that we already have lots of existing standards out there that solve various little pieces of it. They just aren't very well integrated. So the real question is, how do we integrate it and handle the vast set of use cases, which often have quite different requirements together? And in fact, a lot of interesting use cases in IoT are in fact crossing verticals, integrating energy with vehicles or whatever. So these gaps are where we have to do a lot of work to really think really hard about the use cases, requirements, and existing standards, and how we can make things better, and not just create yet another point of interoperability of conflict. Anyways, these gaps are things that have come up, but we're not talking about solving these necessarily with new standards. we're going to be talking about working with existing standards. So GIS integration, there's lots of standards already for GIS. So the question is, how do we connect to those, and how do we use them, and what kind of use cases would they show up in? And actually, GIS brings me to the issue of digital twins, and actually talk about 3D digital twins, by which I assume they mean I want to visualize some data from a device in context, and have like a simulation of that device in like a virtual reality situation or augmented reality. So we're actually working with OpenAR, we're working with Open Geospatial Consortium to discuss the use cases for this. And digital twins in general also are a large application area, and there are other organizations that work on different definitions of digital twins. But I think that the key point of overlap here is you need to know where things are, what shape they are, what they look like, their 3D model, and maybe their motion, right? And these are all GIS topics. I don't know if you want to dig into other things, but other aspects of digital twins are things like historical data, things like shadowing devices that are sleeping, so maybe you keep the last state. Things like visualizing data actually. So I think I just don't want to have just a box representing a sensor. What I really care about is the data from the sensor and what it looks like, and getting notified when there's some emergency condition, and so forth and so forth. And so I also want to be able to visualize data and understand it as part of the AR thing, and that's the real goal. I think this also relates actually to dashboards under cities, which is that a lot of times in the smart city, what you want to get is the big picture. And this also relates to one big use case, which is an emergency response, right? Suppose there's an earthquake or a tsunami, you want to know what's going on so you can deploy resources where they're needed. And so a dashboard is one way to integrate various information in a geographical, 3D context to make decisions.
Thank you. An excellent question as well, an excellent response as well. All right, so I want to direct the question to Kaz. You stressed upon collaboration, and we all know that collaboration is key, important. It's very crucial to address some of the critical challenges in the market, especially in smart cities use cases. So in your view, how would you foresee the collaboration between the ITU and the W3C in standards development activities would actually be an enabler, a key enabler to face or to address the smart cities challenges?
Yeah, that is a great question. And as you might know, so we have been talking with Gimmerly and SD20 for a while for the WOT platform discussion. And I believe we should continue the discussion and extend the discussion for smart cities purposes as well. So meaning use case discussion, requirements discussion, and further reason, and getting actual stakeholders from all over the world, including Asian countries, Korea, China, Japan, and so on, and also Western countries, and so on, and even the other standards organizations as well, so including ISO, IEC, and so on. And this collaboration, which can and should start with this collaboration, I mean, ITUT, SD20, and W3C, WT. Yeah, and we are generating another dedicated interest group, meaning discussion group for use cases and requirements for smart cities discussion as well. So that group within W3C should be also involved in this collaboration.
Thank you very much. Thank you.
Thank you.
So now for a little bit technical discussion, maybe a technical follow-up question directed to Sebastian, Dr. Sebastian. So you provided an excellent deep dive of some of the key technical features and elements present in W3C. And so my question to you is, what kinds of protocol bindings that you think is, is in the roadmap in W3C now, and that will be included in the very near future. Of course, in future updates of the specifications.
So, so as already presented, we have already I would say a huge set on protocols that we have already implementation, and I would say also blueprints in specifications and so on. And what you should also know that we are very focusing also to be aligned with the originators of the SDOs that have invented or have developed this protocol. So currently there is activity ramped up between the OPC Foundation so that we have a standardized, formalized OPC-UA binding for the Web of Things. Yeah, so this is currently ramped up. And another activity we're just starting right now is to have a formal definition for a BACnet binding. So BACnet, for example, is also very important for smart city scenarios because commercial buildings and stadium, office building, airports, and so on, they using this kind of technology. And now there is also initialize this activity to have also official BACnet binding for Web of Things. And this is what is currently on the roadmap. So, and as already shared in the slides, you are welcome to have a look what is already implemented. So typical everything is open source, and we have implementation that we are using in the Plugfest to try it out if our working assumption is really working in that way what we're expecting. And you're welcome to have also look on that and play around with it, with your devices, with your specific devices, with your protocols, and
Thank you. Thank you very much, Sebastian, for the excellent contribution and the excellent presentation. So the final question to Rong from China Mobile. You have presented an implementation in China Mobile on Web of Things. So can you highlight the key standards that you have used in your implementation, and what key lessons that you have learned? How did you manage to implement your whole solution out of the different technological layers from different, I presume, standardized specifications out there in the industry?
Thank you. Sorry. Okay. For our implementation, I think we just focus on the data format, and we just give some rules to abstract the data about the devices. So we we will provide many choice for the user to choose for the protocol. In our solution, user first generate his same model based on the abstract rules in the platform with our tools. Then we will generate the payload. How to generate the payload in the in our SDK for the underlying protocol. We will choose the suitable one which that the users choose. So we just coordinate these two paths. For manufacturers, they only should understand they only need to understand the semantic of the devices, but they can ignore how to implement the protocol. Yes, so it can lower the costs of the development of the manufacturers, which is our purpose. Yeah.
Thank you very much for the explanation. And at the very end, and before passing the floor back to Chiara and to Nasser, Chairman of Study Group 20, I would like to thank all of you, all the speakers, for an excellent line of presentations. And I can see quite a lot of activities as well in the Q&A, and most of the questions, if not all, have been also addressed and answered. I would recommend contacting all of us, all the speakers and all the experts offline for further discussions and for further follow-up activities. And I would stress on the importance of collaboration. It's very beneficial and very important for all of us, the standardization community, to work together to try to address the common problems that we are currently facing in the industry. Collaboration between the ITU and the W3C is indeed strategic and important, and I can see many potential areas of collaboration in the future. So thank you very much, and session 1 is over. So over to you, Chiara.
Thank you for that excellent moderation, Dr. Rami. And of course, thank you as well to all our panelists for the very insightful discussion. I would now like to call on Mr. Nazer Al-Marzouki, Chairman of the ITUT Study Group 20, to give his closing remarks. Mr. Al-Marzouki, the floor is yours.
Thank you very much, Chiara, and thank you very much, Dr. Rami, for the excellent moderation. There were a number of questions being raised, and due to the time constraints, it was not able to answer all the questions, which shows the importance of this topic. And also, you have mentioned a very important point, Dr. Rami, with regards to collaboration between organizations. And in this case, I think the collaboration between ITUT Study Group 20 and also W3C is also very important. I look forward to, as a chairman of Study Group 20, I look forward to strengthen this collaboration with the W3C. So I thank you, Dr. Rami, and also I'd like to sincerely thank all the panelists and all the attendees who joined this webinar. So today we have discussed the architectural aspects of Web of Things, their use cases in smart cities, and the role of standards in their implementation. With the world still facing global challenges such as climate change, sustainability, not to mention the pandemic, there is no doubt that more people will see the transition to smart cities and digital transformation as an opportunity to tackle these challenges. ITU is committed to working with all global stakeholders to co-create solutions that will help the global community to move forward together. As some of you may know, this is not the last webinar of ITU webinar series on digital transformation for cities and communities. This series of webinars will continue until December 2022. I want to take a moment to express my most sincere appreciation to those of you who have joined us in our journey. The series started at the beginning of September 2021. We are grateful to have received very positive feedback from the participants and speakers. And by the way, when this webinar started today, we had 101 participants. So which shows that the value and also the importance of these webinars, and sharing knowledge is really important. Organizing a webinar series like this is something of a new adventure, even for us. That's for your feedback. We have learned from this experience, and we will continue to improve the quality of and our approach to webinars. We hope that we shall be able to count on you. We will be able to count on your support next times as well. Now, I have also requested that TSB, after each webinar, they develop a sort of a document where they have a number of recommendations that we can take into account in the future meetings. So let's say like a sort of a feedback or giveaway from each webinar session that we can learn from, and also based on that, maybe take some actions at further meetings. If you have any questions or feedbacks regarding the webinar or the work of ITU on digital transformation for people-oriented smart cities, please feel free to reach out to TSB, mainly to Christina Bueti at the ITU, and we would love to hear from you. Please also be informed that the presentations delivered and the recordings will be made available on the ITU website. I thank you all for your support, for your participation. I know some of you are connecting from regions where it's now too late at night, and I really appreciate all the efforts and joining us at maybe in some places it's really late at night. So I thank you all for joining and wish you all a wonderful rest of the day. Thank you very much, and hope to see you in the next webinar. Thank you very much. Goodbye to all.
Bye.
Bye.
Thank you.
Goodbye.
Thank you.
Bye.
Bye.
Thank you, Dr. Rami. Goodbye. Thank you, Sebastian.
Bye.
Thank you. Bye.
Thank you all. Thank you, Dr. Lee.
Yeah.
And by the way, happy Lunar Year to our colleagues from the Asia region.
Thank you. Thank you. Yeah. See you next time. Bye.
Yeah.